Okay, we're live on YouTube.
We
Everyone can see your game. It's 10, what, 9?
yes.
All right, live on TikTok.
Hooray! Who's live on TikTok? I'm live on TikTok.
What's going on TikTok?
What's going on TikTok? I'm going live on TikTok.
What do you think? Do you like to stand for me and Doug for video POV, like a consultant?
Yeah, I do. Can I erase all those boards?
Yes, of course.
Don't say of course. Don't say of course like that.
Of course. Hey, have a great show. I'll be monitoring downstairs.
Thank you. All right. Welcome to Math Thursday. I hope everybody's having a great couple months of school. Being back fully in the swing of things. You're probably getting ready for first big exams and all of that. So let me know if you have any questions. Let's get into it. Any math questions or anything like that. So we'll start off with a pretty simple equation. Let's do that. Yeah, there we go. All right, so once you guys have this figured out, go ahead and pop it in the chat and we'll get into it. If you have any other concepts or anything that you want to get into, feel free to put them in the chat. So the live stream now is usually we stick between like pre-algebra through algebra 2. So some of the concepts might get a little bit more some of the concepts that you're asking me to go over may be a little too advanced for what we do on this channel, but still put your questions in the chat because we have a great community and they might be able to, somebody else on here might be able to help you out. You know, I always do my best to try to get to everything, but you know, usually the chat fills up pretty extensively and I'm bopping between two different streams, one on YouTube and one on TikTok. So sometimes, you know, what I see on that chat is different from what I see on the other chat and all that kind of stuff. But okay, so let's see. So Peyton, solving a system. Yes, a system of equations. Can do that. Let's start my note. Gotta start my little list. Oh. All right, so Peyton, while you're waiting for me to get to systems, why don't you go ahead and solve this equation that I've got up on the screen. Yep, so we are solving for x. I got some 7s and some 9s. Let's see. Wow, we're getting a lot of different answers. All right, I'll keep this up for just a couple, let's just say about 2 more minutes, we'll say. Maybe a minute and a half. Ooh, Brandon, what's my favorite math topic? I really love quadratics, but I think my ultimate love is like trig. I really like trig. I like the trig ratios, the trig properties. I don't really like graphing them that much, but they're good. Nice. So Brandon, you're teaching 8th grade algebra. What's your favorite topic to teach? And that's the other thing, is that there's a difference between like, what do I love to teach and what do I love to like learn about and work out? Okay. All right. Jose, we don't really get into calculus here. We mainly kind of end around like algebra 2 trig. But if you have a specific question, put it in the chat, because there's a really good community here that may be able to help you out with any question that you have. All right, so let's get into this. So I see a lot of people saying distribute first, but I actually don't have to distribute. I don't have to, because it's 2 times this 3x minus 4. Over on this side, these are both even numbers, so I could actually go through and divide both sides by 2 first. So now this leaves me with just 3x minus 4 equals 4x plus 10. No, it doesn't leave me 4x plus 10. Oh my gosh. It's been a long week. 2x plus 5. Oh, man. All right, so now I've got this pretty straightforward equation. I'm going to add 4, add 4. So I have 3x equals 2x plus 9 minus 2x, which gives me x equals 9. Ta-da! And whether you distribute or divide first, it doesn't make a difference, because the answer is going to be 9, okay? So you don't have to distribute. You can, because this is just multiplying here, you can just divide by 2 and divide this side by 2, okay? So if you divide everything by 2, it's fine. I can still, it's okay, okay? Oh yeah, there's lots of ways to approach math questions and equations and things, and which is one reason why I really like math, is because especially the upper level maths, there's so many different ways and there's so many different choices that you can make in how to like go about solving a problem. Okay. So I divided both sides, but just over here, 4x, 4 divided by 2 is 2, 10 divided by 2 is 5. Over here, the only thing that I could actually divide is that 2. Boop. Okay, and that just cancels out, so you're left with 3x minus 4. All right, so Peyton asked about solving systems. Let's see, somebody else was asking. Okay, radical expressions, phi or FYE. What do you mean with radical expressions? Do you mean just simplifying radicals, or do you mean like adding and subtracting and multiplying and all of that together with them? Okay, let's see. Germany, 100 on your 9th grade math test today. Woo, that's excellent. Okay, yep, so whether you multiply through and distribute, Or if you don't and you divide by 2, you're going to end up with the same answer. The value of x equals 9, that's the only way to get that to work. Okay, so let's see, systems of equations. Okay. Ooh. So we're just going to stick with linear equations. And what we're going to do is, so a system of equations is, if we start out thinking about it on, let's see. Positive and negative graphs or functions explain how to prove parallel lines. Aurora, do you mean like a geometric proof, like actually writing out a proof, or just finding parallel lines? Okay, so with a system of equations, if you think it's easy to, or it's easier to visualize what's going on when you actually like graph them. So I always start with talking about systems of linear equations, because if we have a line like this, okay, it's just a horizontal line. So this is 1, 2, 3, 4. So this is y equals 5. Okay. And then I have another line here. Okay. So I have these 2 lines and they intersect in one spot. Now, all of these points on here are solutions, right? They're pairs of x and y values that work with that relationship. Right? So in this case right here, where this crosses, that means that the x value and the y value are both the same in both of the equations. Now this one, we know that it's where y equals 5, right? Because this one, on this line, every single y value is going to be 5. So we just have to figure out, okay, what x value is this line going to have when y is 5? Okay, so what we're looking for is, when we have a system of equations, we are looking for that intersection point, because that is a point that solves both of the equations. Now, since we're trying to figure out where they both, what values solve both of them, right? Remember, we've got x equals x and y equals y, which seems really sort of silly to be that. We're like, yeah, of course, x equals x and y equals y. But those of you who are in geometry know that, like, this is kind of an important thing to talk about, right? When you're writing a proof and things like that, the reflexive property, right? So at this intersection, my x values are the same for both equations and my y values are the same for both equations. So I can use that to solve a system of equations, whether I have it graphed or not, okay? So if I don't have it graphed, that's okay. All right, so we've got, let's just start out with a bang. Let's go x plus 7y equals 9. And 2x minus y equals 18. Okay. Oh, Josh, parallel lines with a transversal. I'll put that on the list, okay? Okay. So this is a system of equations. Okay, so if we think about, these are 2 lines, right? We could rewrite these as y equals mx plus b, not a big deal, right? We could graph these lines and we could see where they intersect, or you can also just solve the system of equations using a lot of different ways. So one way is by graphing, but graphing isn't always super reliable because the solution isn't always at like a perfect lattice point. But what you can also do is, another method to solve these is, I like doing elimination. Which is where, since this x and this x are the same value and this y are the same value, I'm going to combine these 2 equations because the x's and the y's are the same values. I can combine these but I'm going to do it in a way that actually gets rid of one of the variables. Because solving an equation with two variables, if it's just an equation, like if it were just that, I could find a lot of different values that would solve that, right? But I'm not going to be able to like pick one specific value if that's all the information that I have, right? So what I'm going to do is I'm going to multiply this whole top equation by 2. The reason I'm going to do that is because I want to get rid of the x's. So I'm going to bring that down to here. So I'm going to multiply everything by 2. So this becomes 2x plus 14y equals 18. Okay. Now what I'm going to do here is I'm going to subtract. Because if I subtract these, I get 2x minus 2x, the x's go away. Negative y minus 14y is negative 15y. And 18 minus 18 is 0. It's not an error, it's just 0. 0 can be an answer. Okay, now anything times 0 is 0. So that means that y equals 0. It's not no solution. There is a solution in here. It's just 0. That's okay. 0 can be a solution. So now I'm going to go back up and I'm going to plug this in because up above, I'm going to go all the way back to one of my original equations. And I'm going to plug in this value for y. So I'm going to do x plus 7 times 0 equals 9. So that would mean that x plus 0 equals 9. So x equals 9. And I can double check this. So I can say, okay, so if x is 9 and y is 0, so 2 times x would be 18 minus 0 would be 18. 9 plus 7 times 0, which is 0, equals 9. So my solution, which would be my intersection point, would be 9, 0. So 0 doesn't mean that it's no solution. 0 just means it's 0. Okay. Now it gets a little bit crazy. Well, not crazy, but it gets a little bit funky when you're talking about slope, right? Is the slope 0 or is it undefined? That kind of thing. But that's a totally different situation. Okay. All right. So those of you who may be new here, welcome. This is Math Thursday. So I've been a math teacher for over 20 years, and I'm here to help you with any math problems that you might have. So any questions that you have, any concepts that you want me to go over, anything like that, pop them in the chat. We usually focus on pre-algebra to algebra 2. So getting into, I saw somebody asked for a chain rule. So that's a little bit more advanced than what we typically do in this segment, but still, if you have a question, put it into the chat because we have a great community here that may be able to help you out. I'm doing my best looking at all the chats that are going. And so I have a list over here that I'm keeping for different things for what we can do. All right. So that is solving a system of equation using elimination. Okay. Okay. So I see quadratic equations. All right, Josh, I'm doing parallel lines and transversals after radical expressions, okay? And then we'll do quadratic equations because you guys know I love them. Okay, so radical expressions. So radicals are totally radical. So when you're looking at so what is a radical? A radical is like a square root. It is a square root. Typically, it's a square root. Okay. All right. So square root of 5. Now, this is an irrational number, right? Square root of 5 can't be simplified. Okay. But what we can do is we can work with it. Okay. Now, if I have square root of 5 times square root of 3, what this actually becomes is this becomes square root of 15. Okay. Because they're both under the square root and I'm multiplying them together, I can multiply that and make it the underneath the radical. Okay. Now another thing that I can do is if I have something like the square root of 8. Okay, the square root of 8 is not a perfect square, but it's made up of perfect squares, right? Square root of 8, so 8 is 4 times 2. So the way that I could simplify this square root of 8 is I can take the square root of 2, right? So now just like this square root of 15 was square root of 5 times square root of 3, square root of 8 is square root of 4 times the square root of 2. Now the square root of 4 is 2. Square root of 2 is still just square root of 2. Okay, now I know this can get a little bit confusing with all these 2's. All right, so I'm going to draw this one just a little bit more turquoise. Okay, because those two 2's are the same. Okay. Usually with these simplifying radicals and radical expressions, you're typically seeing that in 10th or 11th grade in Algebra 2. The grade, you may have seen it earlier, you may see it later. It doesn't really make a difference, but typically you work with these pretty extensively in Algebra 2. Some pre-algebra teachers may start to expose you to this, which is great, I think, because this is one of those things, kind of like simplifying fractions, like you need to see it a couple of times every year before you really start to clue in on it, okay? All right, so this is simplifying a radical. We can multiply them together and they go underneath the radical. You can kind of split them apart like that. Okay, so if you have something like 5, actually, you know what, wait, hold on. I'm gonna write this in blue still because these are still sort of like our rules, sort of. So if I have 6 root 5 plus 3 root 5. Okay. So because these are both root 5s, I can just add them as if they were like an X or an A or a B, right? I'm just going to add the coefficients. So if I have 6 root 5s and I add 3 more root 5s, I have 9 root 5s. Okay. So when you're looking at radical expressions like this, a lot of times you're going to have to do sort of all of this at once, especially this and then this. So you want to simplify all the radicals first, then start combining the like terms. So, oh, I don't like this one. So let's see. So square root plus 3 root 2 minus root 10. Okay. So here we go. So looking at this, we've got root 18, root 2, and root 10. So on the surface, we go, I can't simplify any of that. Nothing is the like terms, right? They don't have any like roots. But I need to double check to see if any of them can be simplified. Okay. So root 18, and we think about, are there any perfect squares inside of 18? Or are there any perfect square factors of 18? And there are, right? It's 9 times 2. So the square root of 9 is 3. And the square root of 2 is the square root of 2. So now you see that the square root of 18 is actually 3 root 2. Because again, 18 is 9 times 2. The square root of 9 is 3. The square root of 2 is square root of 2. Plus 3 square root 2. Now 10, can we simplify 10? 10, the factors of 10 are 5 and 2. Neither one of those are a perfect square. So it's going to stay as square root of 10. So now the only thing that I can do here is I can add this together. I can do 6 root 2 minus root 10. And that would be as simplified as I can make it, okay? Because I can't combine any other like terms or anything like that. So that is how you would work with simplifying radical expressions, okay? How do we use these radicals in math past simplifying, and how is it usable? Oh man, when you get into when you're getting into some quadratics and things like that, and you're working with radicals a little bit more extensively, this becomes a lot easier to work with. And especially like when you're working with trig ratios and trig functions and things like that, that's all here. Okay, so we've got systems, radical expressions. All right, parallel lines and transversals. I think it was Josh that asked for this. So Josh, I hope you're still there. Oh, here's all my other boards. Here's all my other boards from what we did last week. Look at this. We did piecewise functions last week. That's fun. I do like piecewise functions. Here's the other piecewise function. All right, so we're going to do transversals and parallel lines in just a minute. Let me just erase my boards. Some quadratics. Graphing quadratics, factoring quadratics. We'll do all of these again, I know. Okay. Hi, Sarah. Okay. All right, so parallel lines with a transversal. Here we go. So we've got two parallel lines. What does a parallel line mean? It means they're never going to intersect. Okay. So we're going to mark these as being parallel. That's what that little line means. So here we've got parallel lines. So parallel lines means they're never going to intersect because they're going at the same slope. Okay. So the way that they intersect something is going to be in the same way, right? So when you have two parallel lines or a pair of parallel lines, and then you've got this line, that's called a transversal, okay? So this transversal is a straight line, even though it looks a little crooked on camera, but it is a straight line. We're representing it as a straight line, or it's being represented as for a straight line. So because this angle and this angle are the same, these two intersections are going to be identical, right? So it's kind of like when you're driving down a street and there's all these cross streets, you're intersecting them at the same point. You know, if it's a straight road, you know, here in Detroit, we have a lot of these where you've got these parallel lines, and then you've got a transversal cutting through, right? Woodward and Gratiot and all that. And so the intersection is going to be the same every single intersection, okay? So whatever this angle looks like here, it's going to be the same as this angle here, because those are called corresponding angles. So this one, like, I like to think about it as like, it's like the bottom right. So the one in the bottom right is also going to be congruent, okay, to those two. They're going to be the same, okay? Now this angle here is also congruent here because it's a vertical angle, but also it's vertical, or it's congruent down here because they are also corresponding. Okay, so these are corresponding angles. These are corresponding angles. These are vertical angles because they're directly across from each other. These are all congruent angles. On the other side of this, let's do light blue. This angle is congruent to this one because they are also corresponding angles. And this one here, and this one here. Those are corresponding angles also. So everything that I've marked as blue is congruent and red is congruent. One blue and one red is always going to add up to 180 degrees, no matter where it is, okay? So if I were to take, because somebody asked this, because they are a linear pair. So like these two, those are a linear pair. They're gonna add up to 180, okay? So a linear pair is when you've got two angles that make a line, okay? They're gonna be adjacent, which means they touch each other, right? They share a side. and they form a straight line. This right here is a linear pair. They're going to add up to 180 degrees, right? This is a linear pair because they make a line. It's a pair of angles that make a straight line, okay? Now, there's lots of other things that go into these, like alternate interior, alternate exterior, same side, or consecutive interior, consecutive exterior. So we've got vertical angles, we've got corresponding angles, right? Alternate means that it's on either side of the transversal, okay? So alternate angles would be like one on this side, one on this side, okay? Same side or consecutive angles would be on the same side of the transversal, okay? So what we usually talk about is like alternate interior, alternate exterior. Interior means they're inside they're like between the parallel lines. Exterior means they're outside of the parallel lines. Okay. So alternate interior angles. Alternate interior angles are going to be here. Okay. They're both inside the, let me see if these will stand up. Will these stand up? Ooh, almost. Let's see. I'm just trying to use. Okay. All right, I'm going to use these two caps. So alternate interior angles are these two here. Okay. Because they're inside the parallel line, so they're interior, and they're on either side of the transversal. Now, if you notice, they are both red, so alternate angles are always congruent. Whether they're exterior or interior, it doesn't matter. If they are alternate, they are congruent. If they are same side, they are supplementary. So same side or consecutive interior would be these two. Okay, one blue, one red. They're going to add up to 180. And then we've got alternate exterior. Again, they're going to add up to 180. They're still on the same side. Did I say alternate or consecutive? I meant consecutive exterior here. I'm sorry. Consecutive exterior angles are out here. Okay. Consecutive interior angles are here. Consecutive is always going to be supplementary. And again, it doesn't matter which side. These are consecutive interior. These are consecutive exterior. Okay. This is corresponding. These are vertical. This is a linear pair. Alternate interior are congruent. Alternate exterior are congruent. Okay, so alternate again is on either side of the transversal. Interior is inside the parallel lines. Exterior is outside the parallel lines. Same side or consecutive is on the same side of the transversal. Okay. Kanye fan. Okay, triangles. I'll go over triangles a little bit. Yep. So altitude, median, all that. Got it. Okay. All right. So that is parallel lines with a transversal. All right. One is factoring polynomials. So T-Money, we don't really get into calculus in here, but if you have a specific question, you can put it in the chat because there might be somebody who's able to help with you. So geometric proofs are really hard to do in this setting because they take so much, they take so much room, and there's so many postulates and theorems. And so going through proofs here is a little bit tricky, but my biggest piece of advice on when you're doing proofs, everybody's getting into proofs right now. is to make sure you break down every single little statement that you have, and come up with a string of logic before you start writing the proof. That's my big thing. Rainbow monkey logs. I can do a little bit of logs, just kind of basics. I can do a little bit of logs. Ooh, Kanye fan, biology. I love biology. What do you need help on in biology? Okay, let's see. All right, we did the transversal. Okay, quadratic equations. Okay, so solving quadratic equations is, there's a lot of different ways. It's sort of like when you are, oh my gosh. It's sort of like when you're solving systems of equations. When you're solving systems of equations, there's different ways to do it. I love quadratic. There's different ways to solve a quadratic. It just depends on, ooh, I don't like this marker. It just depends on the situation. Okay, so here we've got x squared minus 2x minus 15 equals, actually we're going to do equals 15. Okay. So first things first, for solving quadratics, almost every single time you're solving a quadratic, you need it equal to 0. Okay, now unless you're doing completing the square, you don't need it equal to 0 right off the bat. Or if you're doing just like the square root property, it doesn't need to be equal to 0. But every other like way of solving quadratics, it needs to be equal to 0. So that's usually kind of like my default, right? That you just kind of make it equal to 0. So to make this equal to 0, do x squared minus 2x minus 15 equals 0. Now from here, I have choices. Okay, well, I had choices to begin with, but hi, Max. Is this the Max that I know? That I see every day at school? Completing the square root x squared has a coefficient. There's no reason to do that. Why would you do that? You don't need to complete the square on that. Oh my god. Okay, so x squared minus 2x minus 15. So again, I have choices. I can do quadratic formula. I could complete the square on this one. I'm not going to, but I could. Or I can factor it. So usually the first way that you talk about solving quadratic equations is through factoring. So when we're factoring, hi, Eleanor. Is this the Eleanor that I see almost every day? Okay, so x squared minus 2x minus 15 equals 0. So I'm going to solve this because I can factor this. When you are factoring, what you're looking for is two numbers that multiply to negative 15 and add to negative 2. Okay, so they multiply to negative 15. So I think about all of my factors that go to 15, 1 and 15, 3 and 5, and then I'm back at 5 and 3 and all that. Since this is negative, that means that one of these is going to be positive and one of these is going to be negative because they need to multiply to equal a negative. So they also need to add to negative 2. So when I look at that, I say, okay, well, minus 5 and plus 3. Negative 5 times 3 equals negative 15. Negative 5 plus 3 equals negative 2. So when I find these are my binomials. So I can go ahead and I can jump right in and I can say x plus 3 times x minus 5 equals 0. So for solving these equations, for solving these quadratics, you're going to come up typically, usually, quite often, there are two solutions. Okay, not always. I'm not saying always. Typically, especially when you're factoring, especially when you're first learning these, your teacher's probably going to pick ones that have two solutions. or two values that are going to make this true. So now I've got two things that are multiplied together to equal 0. In order for that to be true, one of these has to equal 0, right? Now they can't both equal 0 because this x value is the same. But I want to figure out what values for x make these 0 to multiply together to equal 0. So I'm going to split this. I'm going to do x plus 3 equals 0. Because if that one equals 0, the whole thing equals 0. And if x minus 5 equals 0, if that one equals 0, this whole thing equals 0. So x could be negative 3, or x could be 5. If x is negative 3, or if x is 5, this is true. Okay, and we can plug that in. So negative 3 squared is 9. Minus 2 times negative 3 is positive 6. So 9 plus 6 does equal 15. Check. 5 squared is 25. 2 times 5 is 10. 25 minus 10 is 15. Check. So these are my two solutions, right? My two solutions are negative 3 and 5. All right. Let's see. So how would you write this in an answer? So the way that you would show this in an answer would be negative 3, comma 5. Now we do these curly braces here. We do the curly braces because that means that it's a list of numbers. If we just had them in parentheses, it would look like it was a coordinate point. That's not what we're going for, right? So we've got this negative 3 and the positive 5. Okay. All right, so polynomials, you got to be a little bit more specific about teaching polynomials. I'm not sure what you are looking for. Okay, so ortho center. I'm going to talk about the triangle stuff in just a minute. And then I'll put scientific notation on here. And then actually, when I talk about the triangle stuff, there's a question over Michaela, included and non-included side. So I'll do that for the for triangles too. Okay, so let's do a little bit of geometry. Yay! Geometry. Remember, we're not going to get into proofs on this. We're just going to talk about like logic and things like that. But then you can go through and use this logic, this string of logic that we talk about in your proofs. That's fine. Okay, so with a triangle, got a couple different things going on. Okay, so just a basic. We're just going to do a basic triangle. Okay, there we go. Let's do triangle DEF. Everybody does triangle ABC. We're just going to do DEF. Okay. So we can have a few different things. So with a triangle, you've got a lot of different things that are going on. So you can have something called a median. Okay. A median is going from the midpoint or from the middle of one side, and it's going to go to the vertex of the other. That was terrible. There. So that is a median. So what we know then is that this point right here is the midpoint of EF, right? So if we call this G, right? So EG and GF are congruent. That's what those markings mean. Okay, so this would be called a median. Now, if this were a 90-degree angle, now it's called a perpendicular bisector because it's perpendicular and it's a bisector. It's through the midpoint, so it's perpendicular bisector. Okay, so that's what that would be. So median just goes through the middle of one side to the vertex of the other. Okay, if we think about like maybe looking at kind of like a more obtuse triangle like that, okay, the median is going to be like, here's my midpoint, and my median would kind of go up like that. Okay, so that would be my median. So these would still be congruent, but it's not at a 90-degree angle, right? So that is a median. Move these a little bit closer. What you can also have in your triangle is called an altitude. So an altitude is from one side to another of the triangle at a 90-degree angle. Okay, so here, that right there, that line right there that's going at a 90-degree angle, that is an altitude. Okay, so it's basically like the height of a triangle. That's kind of hard to see. So there, and it's at a 90-degree angle. Okay. So we've got a median and we've got an altitude. Now a perpendicular bisector is basically both, right? It's a median because it's in the middle, and it's an altitude because it's 90 degrees. So a perpendicular bisector is both of those things. Okay, so an altitude is 90 degrees to the other side. Median is going through the midpoint and making those two congruent sides. Let's see. So then you can get into the centers of triangles, because if I were to draw, so I'm going to go back up to this one. If I were to draw all of the perpendicular bisectors on all three sides. Okay, so there and there. So these two are congruent. And then from here across to there, and these two are congruent. Perpendicular. Okay, so all of these perpendicular bisectors are intersecting to form one of the centers of the triangle, which is called the circumcenter. Okay, now circumcenter, incenter, orthocenter, and centroid are all what I call loaded terms in geometry, which means that if I tell you that this point is the circumcenter, it means a lot of stuff. It means that these are all the perpendicular bisectors. It also means that the distance from the vertices to this center point are congruent as well. Congruent to each other. Okay? So that's the circumcenter of the triangle. Now the incenter is made out of the angle bisectors, and the centroid is the medians, and the altitudes is the orthocenter. Okay, so when you're looking at these centers of triangles, you want to make sure that you really understand what all of these parts are. Okay. All right. So within this, there was another question about the triangles. Okay. So when we're looking at the SAS, AAS, all of the included sides and angles, the order of what they're saying is really what kind of tells you what's being included and what's not. So if we're looking at a triangle, so this is usually when you're talking about similarity statements or congruency statements, when you've got triangles or when you're working with trig or something like that. Okay, so we'll go X, Y, Z. Okay. So if I give you this angle and this side and this side. Okay. So right here, this is a side angle side triangle, because you have a side, an angle, and a side. So the two sides are going to join to make that angle. Okay, you've got that SAS. So side, angle, side, that's included. Okay, so if I had, I'm trying to do this with different colors, but I don't think it's going to work very well. So if I had, instead of that side, if I gave you this angle, right, then it would be angle, side, angle, because you've got the angle, the side, and the other angle. So that side is being included between the two angles. Okay. And so it depends on if you're being asked for similarity or congruence, or if you're trying to do like the trig ratio, like if you're doing law of sines or law of cosines. That was one of, that's just kind of one of the things. Oh, hi, Drew. Aw. Oh my gosh, stoichiometry, really? I love stoichiometry. Oh, I love stoichiometry. Drew, I think I had you in 9th and 10th grade, right? Weren't you in that class? I think you were in 9th and 10th grade that I had you. You remember the sassy triangle? Yep. Okay, so angle, angle, side. So angle, angle, side would be, you had this, right? So then you would have like 10 here or something like that. So angle, angle, side, you're just kind of looking at the order going around. So I know the angle, and I know the angle, and I know a side, right? So I've got the side and this angle, and then I would probably do like that, angle like that. Okay, so I have a side, an angle, and then the other angle. Oh, we talk about angle, side, side triangles a lot. Okay. Okay. All right. Christian, it depends on what your homework is. Okay, so we've got, let's see, we did that. All right, so basic logs. We've got about 10 more minutes, I think. So basic understanding of logs. I don't even know if the person is here anymore. But so the basic idea of a log, which actually logs are way more prevalent than you really think of, like the pH scale. Did you know the pH scale is all based on logarithms and hydrogen concentrations and hydroxyl concentrations? That's all it is. The pH scale, the POH scale. You don't always know that there is a POH scale. With a logarithm, okay, so when we have, okay, so when we have an exponent, we have the base and we have the exponent, which is the power, right? And that's going to equal something, okay? There we go. So we've got b to the power of x equals n, whatever that number is, okay? The logarithm is a way to bring that exponent out, okay? Or to bring it down. So the log loves the base, okay? And it doesn't like the power. Okay, so b to the x power equals n. So log base b of n equals x. Okay, so you do this when you're looking at, when you're trying to figure out exponential functions. Okay, so if I had something like 2 to the x power equals 5. Okay, that would be log base 2 of 5 equals x. Okay, so that would be how you kind of get that exponent out, or that's how you get that variable out of the exponent. Okay. And there's all sorts of properties and everything that you can actually get to. Okay. But this is the basic idea of what the log function is, what the basic understanding of the log is. Okay. All right, let's see. All right, so we got that, did basic logs. Okay. Somebody asked me for studying for AP pre-calculus. No, AP pre-calculus, there are some resources out there, but it hasn't been around for very long. So there are not as many resources for AP pre-calc as there are for like AP Bio and AP Chem, which are things that like I took in high school. So while there's not as many or I guess I should say, it hasn't been around long enough to have as many resources as the more established AP classes have. Oh, I don't know when that's from. But there are still plenty of resources. The College Board, like the AP websites, have a lot of practice materials and things like that. There's a lot of really good resources on Teachers Pay Teachers. And I know there's a lot of video series on YouTube that you can find for some of the creators and things like that. Okay. Okay. All right, so the last thing that I have on my list is scientific notation. Scientific notation. I was actually just working with another student on this today. Scientific notation is a way of writing really, really big numbers or really, really small numbers. Okay, usually there's a whole bunch of zeros involved. So 1.2 times 10 to the 8th. Okay. This is the basics of scientific notation. So scientific notation is, you've got this first number, it's got to be greater than 1 and less than 10. Okay, so 1.2, and then you've got times 10, and this exponent up here, right? Avogadro's number is a great example of scientific notation. My daughter was born on October 22nd, and I was kind of mad because she wasn't born on October 23rd on Mole Day. I was sad, but she was already like 2 weeks overdue, so she was already like 2 weeks overdue, so I was fine with it, but I'm still sort of salty about it, obviously. It's fine. Okay, so 1.2 times 10 to the 8th would be, we have the 1 and the 2, and then we go 1, 2, 3, 4, 5, 6, 7, 8. And there's the decimal, and we fill in with all of these zeros. Okay, so we have a 1, 2, and then 7 zeros. Okay, it is like Avogadro's number. So Avogadro's number is something that comes up a lot in when you're talking about stoichiometry and moles and the number of like atoms in a molecule and the number of so moles are sort of like a dozen. It's like a number of molecules or a number of atoms. Yeah, it's all in chemistry. Yeah, it's all chem stuff. Which if we had more time, I would deeply love to get into stoichiometry, but I don't think we're gonna have time to get into it tonight. Okay. I should start doing like a science Sunday or something. No, what am I talking about? Okay. So when we're working with these, so there's a lot of things that you have to remember about like exponent rules and things like that. A lot of times what you start doing is you start working with these. If I have 1.2 times 10 to the 8th times 3.4 times 10 to the 10th. I'm multiplying everything together, so the order doesn't actually matter. I can do this in whatever order I want. So what I'm going to do is I'm going to do 1.2 times 3.4, and then times 10 to the 8th times 10 to the 10th. Okay, I'm going to kind of split these apart. I'm not really splitting them, but I'm just going to go through this and go through this. So 1.2 times 3.4, so 1.2 times 3.4 in the interest of time. Oh, I got a syntax error. Oh, I typed it in twice. Is 4.08. So we've got 4.08. I am not worrying about sig figs. And then times, so 10 to the 8th times 10 to the 10th. When I'm multiplying these things together, I add the exponents together. So I get 10 to the 18th. And that's going to be my solution. Okay. This is all well and good. It's very simple, straightforward, until you get to something like this. So if I have 3.9 times 10 to the 6th times 4.2 times 10 to the 10th. Okay. I'm still going to do the same thing. Okay. So I'm going to do 3.9 times 4.2 times 10 to the 16th, right? Because I just add those exponents together. So 3.9 times 4.2, it's going to be over 12. It's going to be 16.38. So I've got 16.38 times 10 to the 16th. Great. Problem. This first number needs to be greater than 1 and less than 10. There's my problem, right? So what I need to do is I'm going to move the decimal one spot to the left. So now that becomes 1.638. Again, I am not worried about sig figs. Okay, I think no, I'm not worried about sig figs. Okay, now this is no longer times 10 to the 16th, right? Because I moved the decimal over. So if I move it to the left, I have to add one more space to this because I want to make sure I have the same number of zeros afterwards. So it would be 10 to the 17th. So this is how I would end up with my scientific notation problem. Okay. All right. Cartier. Yeah, I would say this is definitely pre-algebra. Yep. This is pre-algebra, or maybe in your science class. Usually you start seeing this in middle school, upper elementary. Kind of depends on what grade you're in. But yeah, this is something that you typically see in middle school, so pre-algebra. All right, guys, it is about that time. I am going to, I gotta do my little puzzle piece first so I could stay live. There we go. Okay, so excellent questions this week, and I will be back next week to answer more questions, and we can get into more chemistry and all sorts of things. I'm sorry if I didn't get to your question, but I do have a lot of requests. If you want to have like one-on-one specific tutoring or anything like that, click the link and do the stuff. We've got a new bio, a new sign up in the description, and the bio and profile and all of that. Have a good night.